and jump in and unmute yourself like you would in a regular seminar and ask your question. We'll also have David in the chat room for at least in the next half an hour or so, who could handle some clarifying questions as well. And then we always have time at the end of the semester for further questions and comments. So without further ado, go ahead and take it away. You've got an hour.
Okay, thank you very much for giving me this opportunity to present globalization and the law of development. This is joint work with David Atkin, who is here for the first 30 minutes and also on a cost note. So the motivation of this paper comes from a popular and influential metaphor about the process of development. So according to this metaphor, countries sit at the different rungs of the ladder, and each rung is associated with a set of economic activities. And the process of development is described by the process of climbing up these ladders. So as countries develop, which we call they're going to become more capable, and they're going to start to produce more complex products. And building on the knowledge that they produce, they can even become more capable, and they're going to start producing more complex products. And then the process of development goes like this. So this idea has been pushed forward by people like Ricardo Hausmann, and we view that this metaphor is both important and interesting enough that requires formalization. For example, like a paper by Ricardo Hausmann, like What You Export Matters, has now like 4,000 citations. But to date, there has been very little work that formalizes this kind of metaphor. So what we're going to do in this paper is to precisely to fill this gap. So we're going to formalize this ladder metaphor and use this metaphor as a starting point to explore relationships between globalization and the development. So why is previous metaphor useful to think about the relationship between development and globalization? Because the previous metaphor really points out two distinct mechanisms through which development and trade are interrelated. The first mechanism goes from development to trade, which is that if countries become more capable because of domestic shocks like industrial policy, then they're going to acquire comparative advantage in more complex products. Say like China grows, and then China starts to produce more complex products like cars and like airplanes and so on. And that's going to affect trade patterns because that's going to naturally affect comparative advantage across countries. The second mechanism, it goes from the other directions, which goes from trade to development. So countries are going to specialize in more complex goods through the foreign shocks because of entry of other countries to WTO or growth of China, and that's going to naturally shift countries' employment distributions. So because a country is going to specialize in different goods, that's going to in turn affect their capability growth. So for example, as China grows, and other countries like Bangladesh or India now has to specialize in less complex products, because now China has a comparative advantage in more complex products than what Bangladesh used to produce. So now they have to specialize in less complex products, which in turn lowers their economic growth. So we think the distinction between these two mechanisms is important. The first mechanism is really about a standard Ricardian comparative advantage forces, while the second mechanism really points to the dynamic consequences of trade. So trade is going to have dynamic gains or dynamic losses depending on how the specialization affects the capability growth. So the goal of this paper is to try to validate the two distinct mechanisms in the previous metaphor and to disentangle these two mechanisms separately, both from theoretically and from empirically. So on the theoretical side, we're going to first develop a multi-country dynamic Ricardian model and ask the consequences of trade liberalization. So on the theoretical side, we're going to set up a model in a simple way so as to capture the metaphor. And we're going to ask, does trade push countries up the development ladder or hold the countries at the bottom? And in the simple model that formalizes the previous metaphor, we first show that the trade can actually move all countries up the ladder. This happens in this model because in a simple ladder models, complex goods is good for growth, and these complex goods that are good for growth actually face less international competition. So the logic is that if I open up to trade, because there's less competition in more complex goods, so all countries are going to shift their like a production mix toward more complex sectors, which is good for growth. That's why all countries can grow faster. And we find this result is perhaps surprising because in a usual model like this, there are good sectors and bad sectors. If I open up to trade, some countries are going to take good sectors, the other countries are going to take bad sectors. So usually we tend to think that the trade is a zero-sum game from the dynamic perspective. But we actually show that's not the case. A trade can actually benefit all countries through the dynamic effect. And in the second part of the paper, we actually bring this model into the data. And we're going to first ask, try to validate the first conditions. Does producing complex goods raise capability? Is producing more complex goods good for growth or bad for growth? And for need, we need an instrumental variable strategy because specialization is always endogenous to domestic policies. So we're going to use entry of other countries into WTO as an instrumental variable that exogenously shifts the production mix of the country. And we're gonna find that the exogenously shifting your sectoral mix toward more complex sectors is actually good for growth. So we find that the first condition is indeed satisfied in the data, but what we find is that the second condition, it does complex goods. So with the complex goods face less competition or more competition, and we actually find that in the data, more complex goods face more competition. So in the data, there are a lot more countries that are producing more complex products than less complex products. So combining these two ingredients, what we find is that the substantial dynamic losses from trade. So the idea is that indeed we find that complex.
Sorry, can I ask you a question?
Yeah, sure.
Is there a way I can think about, increased specialization in commodities like copper, or like Chile get, as global as trade increases, they specialize more in any of these goods? Are you thinking of any of these goods as essential commodities? Like,
well, we're gonna first focus on like a manufacturing sector. So like our commodities, like in the mining sector, agricultural sectors are out of our focus because we think manufacturing sector is the most relevant to think about these technological spillover ideas. So does that answer your question, or like you asking more about?
Yeah, that's fine.
So the basically what we find is that the because like a complex sectors face more competition, if I open up to trade, all countries are going to shift their like a sectoral mix toward less complex sectors, which are bad for growth. That's why opening up to trade actually going to hurt all countries' economic growth, which we find to be surprising because as simple metaphor describes, we usually we usually expect that these complex goods tend to be exported by fewer countries, but in the data, actually it is produced by more countries rather than fewer countries. And towards the end, we're gonna talk about some robustness checks. Then we're gonna show that it is robust to like how we measure complexity or capability in the data. For the literature, for the sake of time, let me just be brief. So on the theoretical side, we're gonna build on learning by doing literature. But differently from this literature, we're gonna show that trade is not a zero-sum game. So trade can benefit all countries' economic growth. On the empirics, as I have been emphasizing, we really build on this Ricardo Hausmann's work, Hausmann Hidalgo, Hausmann for Nordlake papers to formally think about the relationship between capability and complexity and how trade and growth are interrelated. So here's the roadmap. We're gonna start from a theoretical model and then put some structure, and then we're gonna show like a sharp theoretical result. And we're going to go to the data to actually measure what the complexity means, what the capability means in the data. And we're going to estimate dynamic spillover using instrumental variable strategy. And given those estimates of complexity, capability, dynamic spillover, we're going to conduct counterfactual exercise to study the effect of trade liberalization and the effect of China shock and so on. So far, is there any other question? So let me just directly jump into our theoretical framework. So as I have said, it is a dynamic Ricardian model. So there are many countries indexed by I, and there's a continuum of goods indexed by K, and total measure of goods are normalized to 1. And time is continuous, which is indexed by T, and then labor is only factor of production. And LIT is the exogenous labor endowment in each country I at any point in time date T. So let me describe preferences. So each country is populated by a representative household, and representative household has the following utility functions. So household is going to value a stream of path of consumption, CIT, and CIT, and the within each period there's an SSCS structure. So consumers have preferences over like different sectoral goods indexed by K, and the elasticity substitution across sectors are governed by parameter epsilon. And within each sector, goods are differentiated by countries of origin. Then the elasticity substitution across country is governed by sigma. So it's we assume Hamilton structure. And we're gonna impose that epsilon greater than 0, sigma greater than 1. That's our usual assumptions. And also sigma is greater than epsilon, which means that the goods are more substitutable across countries than across sectors. So this implies that if there is a more falling competition in a given sector, then my sales in that sector is going to go down, which means that I'm going to have less employment in that sector, which is going to play an important role in the theoretical result. So this is, let me describe the technology part. So this is a really key component that describes this ladder metaphor. So we're going to assume that each goods and country are characterized by a single dimensional characteristics. So goods going to be defined complexity, NTK, and country is going to define capability. So this capability captures the position in the ladder. And this FT, we're going to denote like a CDF of complexity across goods as like FT. So each good is has like each complexity, and then there's some distribution over it. And MT is the like just a state of world technology, which collects the vector of like each country's technological level. So as in the standard Ricardian model, we assume the linear technology. So using labor, I'm going to produce a good K from origin I to destination J at each point in time with technology parameter AIJT K. And distribution of this technological parameter is going to be distributed according to some distribution function GIT, which depends on the complexity of that good K and the capability of that countries of origin. So this is where the force mechanism is operating. So this describes that the development, the country's position in the capability ladder, gonna affect my comparative advantage, my technology. And perhaps this is yeah.
Just a quick question. So that A is also going to kind of condense all of like the different input usage and capital usage. So when you go to the data, you don't really have it in the model. Are you going to be able to sort of sort out like what is really the A versus the omitted inputs?
Right, that's a great question. So in the baseline model, we're going to completely omit like those constellations. But in the robustness checks, we actually have like input output linkages in the model at the 2D sector level, and we're going to show that the results are robust to having input output linkages. But in this,
I was more worried about capital and the difference in capital price. Well, that's an input, right?
Well, if there's like a dynamic accumulation of capital accumulation, that's completely out of the focus of like we are not going to have like in that model, in this model. Yeah, but potentially that could be interesting extension that we could consider. Yeah.
Okay, thanks.
So this is perhaps too abstract, like but in the empirical exercise, we're gonna specify this distribution function GIT as a following a linear probability model. So for example, this says that probability that I'm gonna be able to produce the good, so probability that this AIJK takes a positive value is given by some bilateral trade friction, delta IJ, and some like a destination product fixed effects, which captures any demand shocks, and the interaction between capability and complexity. So in this specification, the idea is that more capable countries have comparative advantage in more complex sectors. And let me just describe the second part of the technology, which governs how trade going to impact development, which is describing how this capability, NIT, going to evolve in the future. So we're gonna assume that the future capabilities, the capability growth dot NIT, gonna depend on my current capability, which captures some mean diverting forces or like so on. And not only that, that's gonna depend on my employment distribution today. So this FITL are gonna determine determines the employment distribution across complexity. So if I have more like whether I have more like employment in more complex sectors, or like if I have less employment in less complex sectors and so on. So the idea is that if I produce more complex products, that's gonna positively impact my technological growth because I can build on the knowledge that I used to make. So if I know how to produce motorbike, I can produce cars. If I know how to produce cars, I can produce airplanes and so on. So consistent with notion, I'm gonna assume that the HIT, this function, is increasing in this distribution in a monotone likelihood ratio property sense, so that shifting employment distribution toward more complex sectors gonna raise the capability growth. But perhaps this specification is too abstract, but in the empirical sections, we're gonna specialize to these functional form assumptions. So this is saying that my future capability at T+1 is a function of average complexity of my employment. And beta governs the technological spillover, like how good, whether producing more complex products on average, going to raise my capability or not. And this phi times NIT is a mean diverting forces, and the others are fixed effects.
Are you switching to discrete time?
Oh, okay, but yeah, in the theoretical section for technical reasons, we're going to assume continuous time. But when we bring it to the data, because data is in discrete time, we have to assume discrete time, like discrete time process. Yeah. So competitive equilibrium is defined in a usual way. So we're gonna assume financial autarky. So there's no trading financial assets, but there's a free trade. So at each point in time t, conditional on the state of the world technology and t, the equilibrium is defined in a usual static Ricardian manner. So firms maximize profits, consumers maximize utility, and markets clear. And the dynamics is really how this world technology and T gonna evolve. So given the employment allocations that is determined in a static equilibrium, that's gonna determine what my future capability is, and we can recursively define a competitive equilibrium going forward. And the simply passive consumption is gonna pin down the real interest rate in each country.
Sal, just a quick question. The knowledge accumulation depends upon the share of people in the sector, not like the absolute mass of people. So it sort of means like small countries who are concentrated in one place are going to kind of learn a lot from than a big country that has a lot more people in that sector. So
in this specification, so yeah, like this is like really the share of like people working in like a more complex sectors or less complex sectors. But in this specification, because age can depend on I and T, it can potentially depend on like total size of the country.
Okay.
So that's potentially allowed in this specification.
Okay, thanks.
And also like in the empirical section, we're gonna have a country fixed effect, so that's gonna absorb like any time invariant factor such as size or something like that. Yeah. And so far, like the model has been very general, but perhaps this is too general to say anything theoretically. So we're gonna really specialize into what we call as a Purelara economy. And we think this is really the formalization of the like a Lara metaphor that I showed in the first slide, and which also turns out to be a generalization of the Krugman 1979 work, which is just a two-country version of this model. So we're gonna say that the AIJK, like a productivity of goods K from I to J, are gonna be positive if my capability is higher than the complexity of that good. And in that case, I can produce with productivity AIJT, but if my complexity, if the goods complexity is higher than my capability, then I am not gonna be able to produce the good. So this is really focusing on extensive margin. So as in the simple Lara metaphor, the emphasis of like Ricardo Hausmann's work is really about extensive margin, whether I have a knowledge to produce that good or not. So it's really the focus on extensive margin is really trying to capture this idea. And the important restriction in this assumption is that this AIJT does not depend on K. So all the comparative advantage forces are going to operate across the extensive margin, whether you produce or not. rather than the intensive margin, like whether you are productive or conventional producing or not. So it's really the three key features are embedded in these specifications. If you are more capable, you're more likely to export the good. If the good is more complex, then it is less likely to be exported. And if you are more capable, then you can have a comparative advantage in more complex goods, because it's really, there's a complementarity between complexity and capability. And using this like simple specifications, which really try to capture the like a lot of metaphor by Ricardo Hausman, and we're going to ask what is the difference between time possible capability and consumptions if countries open up to trade. So that's trade. What is the dynamic consequences of the trade liberalization? So here's the result. So in a Purelara economy, the economy I have described before, opening up to trade raises technological capability and consumption at all dates in all countries. So it really says that dynamic gains are, so it really says that trade is not zero-sum game. We're going to have a dynamic gains in all countries. So the SketchUp proof, it works as follows. So consider date zero, like suppose I open up to trade today, then what it means is that there's going to be a more foreign competition in less complex sectors in all countries. Which means that because I face less competition in like because I face more competition in less complex sectors, that means that I'm going to shift my employment distribution toward more complex sectors. And because more complex sectors are good for growth, that's going to raise the economic growth at date zero. So let me just graphically explain this logic. So here, like in the left panel, I am plotting the number of foreign competitors across complexity, across sectoral sectoral complexity. So because like fewer and fewer countries are able to produce more complex products, there are going to be a less and less competition in more complex sectors. So number of countries that can produce less complex sector is much higher than the number of countries that can produce more complex sectors. And this dashed line is the like autarky, degree of foreign competition in autarky, which is just a flat because I am the only producer in autarky equilibrium. So if I open up to trade, competition are going to move from this dashed line to the solid line, which implies that the employment distribution across across complexity going to shift from this flat line, which is dashed line, to this solid line. Because there are a lot more countries who can produce less complex sectors, I'm going to shift my employment to the sectors that I have comparative advantage, which is the more complex sectors. And this is going to happen in every single countries except for the bottom countries. So the bottom country, it's precisely at here. So my employment distribution across sectoral complexity does not change. But other than bottom countries, all countries are going to shift employment distribution toward more complex sectors. And that's going to in turn imply that the higher capability growth at date zero. And we cannot, we don't know whether capability growth is higher or lower after date zero. But what we know from this logic is that whenever capability in trade equilibrium and the autarky equilibrium are exactly equal, then we know from this logic that the capability growth in trade equilibrium has to be higher than the capability growth in autarky equilibrium. Therefore, like whenever like these possible capability touches, they have to diverge again. So then we don't know what happens to growth rate, but we know that the level of capability in trade equilibrium has to be always higher at any point in time t than in autarky equilibrium. And because of that, the consumption in trade equilibrium is going to be always higher than the consumption in autarky equilibrium. That's why like all countries are going to have higher capability and then higher consumption at all dates in all countries.
Yeah, so can you, Masao, so sorry, there's growth in this economy.
Yep.
But we don't know if growth is going up or down here. We just know it's better. Like from a welfare perspective, this is a better outcome.
Exactly. So in terms of level, like it's going to be always higher. Yeah, but we don't know like to compare statics of the growth rate at each point in time.
Because it could be, so is it, can you like cook up a case where growth actually goes down? And
well,
like, you know what I mean?
Right. Look, for example,
Stuff
like
slows down or something.
it was an assumption that there's a steady state of the economy. So like then like in the long run, like a growth rate is going to be both zero in the autarky equilibrium and in the trade equilibrium. So like in this case, the growth rate is not going to be affected
I see. So there isn't. So there's growth like in the steady state, like in the wherever you end up, there's no growth, but there's growth in between. That's what I'm trying to ask. Like, is it because like you have the spillover, and I start thinking immediately that there's that this is operating like a endogenous growth model or something.
Well, right, depends on how. Right. So this H function is really agnostic about like this is a endogenous growth model or semi-endogenous growth model. So if there's some mean reverting forces, we're gonna always converge back to the like we're gonna always converge to the like a constant like n. And but if I don't know if there's a scale effect, then countries can keep growing. So that really depends on this whether phi is greater than 1 or less than 1. So that's
and then when you do but there in this one that case the pure ladder that's with.
Well, Purelara doesn't like assume anything about H function. H function can be like anything, but still like we know the level of capability are going to be always higher in trade equilibrium than in autarky equilibrium. So without imposing any restriction on H function, we can say like robust future about the like a level of capability in trade equilibrium and the autarky equilibrium. Does that make sense? So yeah, but it could be, but we don't know like whether long run growth rate is higher or lower. Like that's going to depend on what the H function is.
So, but just adding to that, I mean, the kind of takeaway here is we don't need to really know anything or say anything about those growth trajectories to make the point that you're better off later, since if at any point you kind of come back to the same level of utility as you had when you were in autarky, you then move away from it. And so we can have a kind of very general model without us having to commit to, endogenous growth model or semi-endogenous, for example.
So let me just say one thing, that this result that dynamic gains for everyone happens because in this simple ladder economy, that really the two key features are playing a role. So the first condition is that complex goods are really good for growth, and the complex goods at the same time face less competitions. These two assumptions are driving this result. So in the data, what we're going to do is to validate these two conditions in the data. And then having established that there are going to be always dynamic gains from trade, we can also compute the bound on the gains from trade. So we're going to define gains from trade as the change in lifetime utility expressed in consumption equivalent unit. So we can bound these gains from trade from the lower bound and the upper bound. So lower bound is going to be simply given by static gains, which is just a ACR formula, multi-sector ACR formula. Because we know that dynamic gains has to be positive, the lower bound on gains from trade has to be always static gains. And in the upper bound are going to be captured by the changing a steady state capability. So we don't know what happens along the functional dynamics, but if the economy were to move from old steady state to new steady state, then that's going to be the upper bound, because I'm going to have a higher capability immediately after opening up to trade. But in practice, transition takes time, so the actual gains from trade are going to be bounded by this lower bound and the upper bound. And this dynamic gains term are going to be capturing the level variety. So if my capability goes up, I can produce more variety, and I'm happier because I have a preference for level variety, which is captured by this 1/1 minus epsilon term, which is how I like new variety. Any questions so far? Okay, so let me just move to the so that this is a theoretical part, and we're gonna go to the data to measure capability and complexity. And after measuring capability and complexity, we're gonna validate the two conditions of whether producing more complex sectors are good for growth. But for the first task we need to do is to what capability N and what complexity NK means in the data. So the general idea of how we're going to recover capability and complexity in the data is to use trade data to review productivity distribution. And given the recovered productivity distributions, we're gonna try to back up our capability and complexity. So we're gonna use two complementary approaches. The first approach is much closer to like what Hausman, Juan and Roderick and Hidalgo Hausman have been doing. So the underlying assumption in this approach is that we're gonna assume that the more capable countries are more likely to like export more complex goods. So we're gonna say a country is more capable if this country tends to export more complex products. And conversely, we're gonna say the good is more complex if this good is relatively more likely to be exported by more capable countries. And we're gonna iterate this logic to recover capability and complexity. And the second approach, which is much closer to the Purelara metaphor that I have described, is that the assumption is that more capable countries should be able to export more goods. And more complex products are going to be exported by less countries because it's harder to produce, so it's going to be less likely to be exported. And both approaches are going to give us a very similar answer. So let me describe the first approach. So we're going to assume that the productivity distribution GIT is given by the following functional form. So the probability is that productivity are going to take a positive value that whether I can produce or not, going to depend on some IJ fixed effects, which captures any bilateral trade frictions, and gamma JK, which captures any destination product demand shocks. And really the key meat of what we are doing is that this interaction between capability and the complexity. So this so in this specification, there is a complementarity in capability N and the complexity and K. So this means that the capable countries have a comparative advantage in more complex products. And we can read what the productivity is in the data by just looking at whether countries are exporting these products or not. So we're going to assume a linear probability model in the data and estimate the following equation. So whether countries are can export the good or not, going to depend on the same functional form assumptions as this, plus some error term, UIJKT. And we're going to assume this error term are going to be independent across product and origin, but not necessarily across destination. So this allows correlated shocks. For example, some countries might be particularly good at doing producing some goods. In that case, our country is going to have a correlated shocks across destinations. So we're going to allow for that. And this is related to revealed comparative advantage measure used in this literature. But differently from this literature, the emphasis is really on extensive merging. It's not about how much you export, it's more about whether you can export or not. And in that sense, it is much closer to the what Hausman and Hidalgo have been doing in this literature. So the how we can identify this capability and complexity from the following from the previous specifications. So let me just outline the logic behind how we can identify this complexity and capability. So suppose we know that the US is more capable than Bangladesh. Then we're going to say the good K, particular good K, is more complex than another good K0 if US is relatively more likely to export it than the Bangladesh. So this means that US has a comparative advantage in goods K than the Bangladesh. So in the data, what it means is that it is taking really the double difference. So this is the relative likelihood of like a US to export goods K relative to another goods K0. And we're going to compare it to the relative likelihood of Bangladesh to export goods K relative to K0. And the difference between this double difference are going to capture how much more complex good K is relative to another good K0. And we're going to move in converse. So we suppose we know that the medicines are more complex than t-shirts. Then we're going to say country I is more capable than another countries if medicine is relatively more likely to be exported than the t-shirt. And again, this going to amounts to taking double difference. So we're going to compute a likelihood of like a medicine to be exported by country I relative to t-shirt. And we're going to also take the difference to the relative likelihood of medicine to be exported relative to t-shirt in the country I0. And we're going to say if this is high, we're going to say the difference between country I's capability and country I0's capability is high. So we're going to iterate this procedure by starting from the guess that G10 members are capable. And assuming that G10 members are capable, we can recover what the complexity is by looking at the relative likelihood of like G10 members exporting certain goods versus the other. And given the recovered complexity distributions, we can then further iterate to recover a capability distribution. And we're going to repeat this procedure to keep iterating these two processes until it converges. And in practice, there's an error term like in this like a UIJK, like in this linear probability model. So we're going to apply law of large numbers to take averages across goods and across countries. Is there any question? So let me go through the data before describing how that.
Wait, I have a question. Like, how does it? Suppose I say it's all the guys at the bottom are the most capable. Like, how does it depend? This algorithm depend on the initial condition. You know what I'm talking about?
We haven't started from the bottom of the distribution, but what we have tried is like for example, starting from G5 or like a G7 instead of G10, but all reasonable starting values are going to give us a very similar answers. But we haven't tried starting from the bottom. We have to check that. We haven't tried that yet. But
yeah, I'm just wondering.
Right. Yeah. I fully agree. Yeah, we should check like whether But for at least for the reasonable like a guess of like what the most capable countries are, like this gonna all converge to exactly the same distribution of capability and complexity. We're going to use our standard trade data set from ComTrade, and we're going to focus on 4-digit SITC code. And there are going to be 146 countries from 1960 to 2014. And as I said, we're going to only focus on manufacturing sectors. And there are 715 manufacturing sectors. And we're going to focus on manufacturing sectors precisely because this idea of dynamic technological spillover seems to be most relevant in manufacturing sector rather than in agriculture or mining sectors. And we're going to follow the standard procedure to clean the data. So this is how the recovered measure of capability looks like. And we argue that this looks very reasonable. So we pick 8 countries that are similar in size, and we are plotting the evolution of capability over time. And because the level of capability is not identified, we always normalize the US capability to be 1. So all these measures is like how each country is capable relative to the US. And we show that we see that the, for example, a country like Italy has been always very capable from the start, but like South European countries like Spain tend to catch up rapidly in the like 1960s to 70s. And later on, like South Korea, like Asian growth miracle countries also start to rapidly catch up like in 1980s. And further later on, like Thailand also started to catch up like toward these European countries, while other countries like Ghana or like Bangladesh or like African countries or South American countries tend to be stagnating at the bottom of the capability distribution. And this is how the measured complexity looks like. So here I'm showing the top 10 most complex sectors. And here like I'm showing the least complex sectors. So we also argue that this also looks reasonable. For example, medicaments or medicine comes at the top, and cars or chemical products, electricity, which we usually think as a complex products, actually shows up in the top of the complexity distribution. And on the other hand, like undergarments, men's underwear, like tires, like wood panels, are the goods that we usually tend to think less complex or requires less knowledge to make, actually shows up in the bottom of the complexity distribution. So we think the measured capability and complexity are reasonable. And we can actually compare like our measured complexity and capability to the earlier work by like Hidalgo, Hausman, like Hausman, Juan, and Roderick. So what they do is to like, so for example, like HHR 2007, like Hidalgo, Hausman, Juan, Roderick, measures complexity by saying if good is relatively more exported by rich country, they say this good is complex. And conversely, if they say the country is more capable, if it tends to export a more complex product. And similarly, like in the later work by Hausman and Hidalgo, they define complexity and capability in the following way. So they say a country is more capable if it tends to like export a lot of products, and they say like the good is more complex if it is exported by fewer countries. And they're going to iterate this procedure to like recover to collect for the fact that some countries tend to export more complex products, some complex products are exported by more capable countries, and so on.
I have a dumb question, if I might ask one little question.
Yep.
Certain countries, such as China, encourage high technology manufacturers to manufacture in China and export their goods from China, such as in the field of optronics, lasers, optical devices, very high-tech products. Those 2/3 of their production roughly are exported out of China. Do you count those as exports, high technology exports from China? Because there's certainly higher technology.
So yeah. Well, yeah. Those are like I think you. Sorry. Yeah, these sectors like Sorry. Can you repeat the question again? Sorry, I didn't.
Yeah, my question is, how does your model account for products that would not normally be made in a country to satisfy consumer demand in the country, but specifically for export, mostly? So there's a lot of American companies, high-tech companies, were encouraged to manufacture in China and were given preferences because they would agree. The UK does that too, like in Wales, to export most of their production out of the country. But if those are considered exports from that host country, doesn't that run a little counter to some of the conclusions in your model? All right.
Yeah, okay. I take your point. I think I got your point. So you're kind of like asking like a country like say firm like Apple or like build a factory in China, and we're gonna in this measure we're gonna say that is the export from China. So we're gonna say that China is exporting really this iPhone high-tech goods. But I guess what you have in mind is really this is like Apple's technology, so it's really US technology. So it's not because China is capable. It's more like US is more capable, and then they're just building a global value chain in China. Is that kind of the concern that you have in mind?
Well, my question is, how does your model account for that? Yes.
Yeah. Okay. Well, yeah, that's the shortcoming of this measure. Like that's like in global intermediate value chains. Like maybe the fact that China is exporting high-tech goods, it's not really about China is capable. It's more like other countries' technological transfer and so on. Yeah. Okay. That's definitely like we are not taking into account. Our model doesn't take into account that. But what we want to emphasize is that the earlier work by like this Ricardo Hassmann's work also do the same procedure. So we just wanted to be as close as possible and to try to formalize the idea like in a similar way. So yeah, that's yeah.
Dude, man, Masao, I think their model kind of rationalizes these kind of policies that China wants. Is that I want these guys to come in, and then I get all that employment in those high-tech sectors, and that's generating spillovers.
Oh, right, yeah.
And that's I mean, that's kind of what's I think kind of interesting in your models. It looks like what China's doing is from their perspective is a good thing to get. You want these companies to be there and just dump a bunch of employment in it.
Exactly. In some sense, our model can rationalize the fact that why like a lot of countries want to like invite like want to have employment in those high-tech sectors. It's precisely because maybe government thinks that these technology are going to generate technological spillovers on the other sectors. So yeah, our model definitely can speak to that type of industrial policy, definitely. And yeah, so what I want to say in the slide is that although we measure complexity and capability in a different way from early work, our measures are line up well with the earlier work by Ricardo Hassmann. So they are strongly positively correlated across time periods, but maybe stronger in the later periods. So this is reassuring in a sense that we are not coming up with totally different measure from what the earlier work has done. But the benefit of this approach is that our approach is that our measure of complexity and capability going to directly map into underlying structural technological parameters. So having the estimates of capability and complexity, we're going to turn to estimation of dynamic spillover, which is really the key condition for the dynamic gains from trade in the proposition. So we're going to specialize the following specification for the H function, which has been very general, but now we're going to assume the following functional form. So my future capability are going to depend on the average complexity of the employment distribution times beta, which is some spillover parameter, and some mean diverting forces, phi, and the country fixed effects, which can absorb any time invariant country characteristics such as size, and also any common wall shock, which going to be absorbed into time fixed effects. And because we don't have data on like employment distributions, we're gonna use this. We're gonna assume that the employment distributions are gonna be the same as the distribution of exports. But the key endogeneity concern in estimating these equations through OLS is that the correlation between this error term and the average complexity. For example, if country is doing industrial policy, then maybe China, for example, want to shift employment toward high-tech sectors, but at the same time, China can be doing other things like try to stimulate economic growth. So in that case, beta are going to be biased towards the upward. We're going to find the capability to grow faster, but presumably that's not because of employment shifting toward more complex sectors, but because of the other policies that China has been implementing. So to deal with this endogeneity concern, we're going to propose an instrumental variable strategy. To the best of our knowledge, it's novel, and we're going to. The general idea behind this instrumental variable is that we're going to use reduction in other countries' tariff as a shifter for the domestic sectoral mix. So say China enters into WTO, that's going to affect other countries' employment distribution because now China has comparative advantage in certain sectors, so that other countries have to shift specialization towards the other sectors, and that's presumably also going to do anything related to domestic policies. So we're going to formally construct an instrumental variable by using a first order approximation by taking the small increase in the trade cost of the entrance into WTO. So because of the necessary structure, there are two variations that this entry of WTO are going to have. So the first is labor demand shifter at the product destination level. So intuitively speaking, this is capturing the idea that now China enters into WTO. China used to export a lot in the southern product market in the US, and other countries also tend to export in the same product destinations, has to shift the employment toward the other sectors. And the second instrumental variable is really coming from the destination level. Now China used to export a lot to the US. Now China can export more to the US. So the other countries that used to export a lot in the US has to shift the employment distribution towards the other sectors. And this is how the recovery instrumental variable looks like. So let me just focus on the, so this higher value means that my employment is shifted toward less complex sectors. So if we focus on 2001, which is really the entry of China into WTO, we see that the Bangladesh, countries like Bangladesh or Ghana, their instrumental value are going up, meaning that because of entry of China into WTO, their employment distribution is shifted toward less complex sectors. But other countries like South Korea, for example, or Italy, their employment distribution is shifted toward more complex sectors. So this is the capturing the idea that maybe China has a comparative advantage in the middle complex sectors. And as China enters, now countries that has capability lower than China has to shift the employment distribution toward less complex sectors, while countries that which are more capable than China, like Italy or South Korea, can specialize more in more complex sectors. And we're going to use this variation to see whether Bangladesh grows slower relative to South Korea after the entry of China into WTO. And this is the first stage regressions. We indeed confirm that the first stage have a strong predictive power, but the variation is more coming from the destination level rather than the final level of disaggregation, which is the product destination level. And this is the IB regressions. So we are estimating this equation, and we are interested in the coefficient beta. which is the first row of this table. Using IB strategy, we find like a highly statistically significant coefficient of beta. So this means that the shifting your employment distribution toward more complex sectors gonna indeed raise your capability growth. And we also confirm the same thing in our latest form regression. So actually, sectors that we identify as complex are indeed good for growth. That's the takeaway from the previous IB regressions. And having estimates of dynamic spillover parameter, which is a key parameter in our model, we can put those estimated parameters of like a dynamic spillover and the measured complexity and the capability into the quantitative model. And we're going to ask what's the effect of trade regulation is in this context. So we're going to ask the following specific questions. We're going to ask what would have happened to the path of capability and aggregate consumption from 1960 to 2014 if starting in 1962 countries were to move to autarky. And we're going to decompose welfare changes into static gains and dynamic gains. So the static gains is capturing the usual gains, so which is defined as the change in consumptions holding capability fixed. And dynamic gains are gonna show the effect of like the fact that the capability is gonna change in trade equilibrium. Trade is gonna change specialization, that's gonna affect my capability, and dynamic gains is gonna capture what's the dynamic consequences of like a changes in capability.
Masao, are you going to control for other things that would lead to a growth in consumption?
Oh, you mean, sorry.
Yeah,
the growth
that was quick. I didn't, in the end, there's other things that are going to lead consumption to grow in that period, like capital deepening or exogenous technology diffusion. How are you going to control for those things in this accounting exercise? Is everything going to show up in the dynamic gains, or are they somehow someplace else?
That's gonna, I think, show up in the static like capital. I think we're gonna recover productivity distribution from directly from the data. So we're gonna hold this productivity fixed, except for the fact that I cannot trade. So I think we are like holding fixed the like a degree of capital deepening, which happens for any domestic reasons. That's gonna be held constant. But I guess you are concerned more like trading like ideas or something, technology.
Yeah,
like
any other factor that we would think would be important that wouldn't be, that's in the first year macro sequence that would not be in this model, like trade in ideas, endogenous growth, or diffusion, or capital deepening.
Yeah, that's not in our model, and we hopefully like by using instrumental variable strategy, we are isolating really this technological spillover. Other things could have happened at the same time, but that's not captured in our model.
Okay.
Yeah. We are not going to do any innovation on estimation of elasticity substitutions. We're going to take from Broad on Weinstein, rating on Weinstein, of the lower nest and upper nest elasticity substitution parameter, and we're gonna set the parameter beta and phi like of the dynamic spillover equations as the estimated value in the previous IB regression table. And we're gonna parameterize this productivity distribution AIJK to exactly match all trade flows. And in autarky equilibrium, we're gonna simulate the autarky equilibrium by generating from the linear probability model that we have estimated in empirical sections. And also we're gonna have non-tradable sector, which is with Globalization preferences. So this is like a key result. So this is showing the CDF, a cumulative distribution function of the static gains for all countries in 2012 and the dynamic gains in 2012. So not surprisingly, we're gonna have a positive static gains. But what is surprising here is that we actually find that the almost all countries have dynamic losses. So like almost like 99% of the countries have dynamic losses, which we found to be surprising, and we first saw that there must be some coding error in this exercise. But the next figure really explains why that's the case. So actually, in the data,
wait. Like go back to that. Like okay, just like so like pick a point on that on the right hand side. How do I read that? Like 0.5, and then so that's saying
0.5
50%
so like
have
of the country have like a dynamic gains are less than minus 1.1% or 2%.
And then
Median
there's
dynamic
like
losses are like a minus 2%.
the median is minus 2%.
Yeah.
And then there's like call 5% that have like minus 50%.
Exactly. Some countries have a substantial amount of dynamic.
And can you just like show some like color on like who are those? Or are you gonna do that next? Like who's the guy with minus 50?
We don't have like that. We have a table in the paper, but these are majority of these countries are African countries.
I see. So it's those guys would look better off.
Exactly. So in general, like poor countries, like African countries, tend to have a substantial amount of dynamic losses, while countries like US or like European countries tend to have very small dynamic losses. So this figure explains why we find substantial amount of dynamic losses. So in the data, actually, like more complex sectors face more foreign competition. While in the simple ladder metaphor, the underlying presumption is that more complex sectors, they may be hard to produce, so they face less competition. But that's not the case in the data. So in the left photo, we are showing the complexity on x-axis and the number of countries are producing on the vertical axis. So we see a very strong positive correlation. So more complex products tend to be produced by more countries. And we can also show some examples. So for example, look, we're gonna pick like medicines, which is one of the most complex sectors, and the men's underwear, which is one of the least complex sectors. And this is plotting the conditional on so this is plotting the number of destinations, how many countries I am exporting to. So for medicine, a lot of countries are export to many destinations, even conditional on exporting. While for the men's underwear, like a majority of countries do not export anything, but even if they export, conditional on being exporting, they don't do export to very fewer countries. So putting this together.
So I'll keep hassling you since like you're down you only have a couple minutes, but just like tell me this, like what does the level of disaggregation matter here? Like there's only like 2 countries that can do mRNA, COVID vaccines. And then, but if I just lump that into medicines, then this would look like there's tons of people that could do that.
Exactly.
You know what I mean?
So yeah, right. So for the data, due to the data constraint, we couldn't go further than like a 4-digit sectors. But we are precisely concerned about that. And then what we did as a robustness check is that we're gonna try to incorporate the difference in elasticity of substitution across different sectors. So for example, like people might think that medicine is more differentiated, or like men's underwear is less differentiated, which gonna be captured by heterogeneity in sigma. So we're gonna put like estimates of sectoral level estimates of sigma into a model, but we still find the same conclusion. That's something we can talk about later on. So like because like these more complex sectors face more foreign competition, if I open up to trade, all countries have to shift their employment toward less complex sectors, which are bad for growth. That's why we find substantial amount of dynamic losses. And we can also ask alternative counterfactual questions. What is the distribution of consequences of the rise of China? So suppose China has not grown from the 1990s, what would happen to like African countries or countries like South Korea in the previous like 30 years? So this figure is showing the dynamic gains from the rise of China. How much countries are like benefiting or losing from the like rise of China on the vertical axis, and the horizontal axis, I'm showing the log GDP per capita in 1990. So we see that a lot of African countries, these yellow dots, tend to lose from China. And why that's the case? Because China tends to be a big seller of Africa's more complex sectors. So China tends to export like complex sectors that also Africa has to compete with. So because China grows, like Africa now can specialize less in those sectors. And also China tends to be buyer of like Africa's least complex sectors. So China tends to import a lot of least complex sectors from Africa. And that's going to also like shift the employment toward less complex sectors. And finally, Africa countries tend to produce fewer goods. So small change in capability tend to have a proportionally large effects on the welfare. So we see a positive relationship between log GDP per capita and then dynamic gains from China, which suggests that the fact that China grew in the past 30 years substantially widened world income inequality. mainly by pushing like a lot of African countries at the bottom. Yeah, maybe I think I'm already 1 hour, but we also did like a robustness check and to measure like a capability and complexity in an alternative way. So the idea is that we're gonna say goods are more complex if it is exported by less countries, and we say the goods are more capable if it is exported by more countries. Sorry, we say the goods are more complex if it is exported by fewer countries, and we say country is more capable if it is exporting more products. But regardless of how we measure complexity and capability, we still find the same conclusion. We find the substantial amount of dynamic losses from trade. So just to conclude, the main takeaway, what we learned from this project is that in a simple ladder metaphor, actually what we find is that the trade can benefit all countries. But in the data, actually the conditions are needed for dynamic gains for all countries are violated in the data. What we find surprising is that the actually more complex sectors tend to be exported by more countries, which implies that the trade realizations are going to lead to substantial amount of dynamic losses from trade. So thank you very much. I think I'm already.
Sorry, yeah, you did okay. Mike asked a lot of questions. So now we'll open up the stream for more questions and comments. Just go ahead and unmute and jump in.
Masao, I'm worried about something that's related to what Mike was talking about in the earlier discussion of the iPhone. You know, in a world where, I mean, just like the way the mapping of sectors into complexity, I mean, what if there are stages of production within a sector? And, you know, there are simple stages and there are complex stages. And, you know, the sort of most complex products are the ones that have the most stages, and it's where it ends up being better to split it up in, you know, across different countries. I mean, this sort of, it seems to be, your results seems to be relying a lot on the fact that the products that are deemed to be complex are exported by a lot of countries. But if we're lumping together, you know, complex and not complex parts of the production chain into one thing, then, you know, the whole model is taking place within sectors, not across sectors.
Right. So yeah, I agree. So yeah, we are concerned about that. So what we could do in the data with the data we have is that we also incorporated input up linkages. So I guess your point is like maybe complex sectors need to have a longer value chain or more input up linkages. So what we did is that because we have data on the input up linkages at the 2-digit level, we have incorporated input up linkages with 2-digit level sectors, but we still find the same conclusion to
Actually, I would say, you know, maybe the more disaggregated, the less likely to be a problem, whereas the more aggregated it is, the more likely this is to be an issue. That you know.
Right. So yeah, if we had a data on like a 4-digit level, like a degree of input linkages, we could have done better. But for the data constraint we have, like we could only do input linkages at the 2-digit level, and then we find, at least at the 2-digit level, like we find the same conclusion. But we cannot say, yeah, we cannot perfectly address like the concerns that maybe the input of linkage is really about the more disaggregated level. So yeah, that's a fair concern. Yeah.
Another point about the previous comment in terms of the stages of the process, this applies not just to high-tech goods. So for example, when Brazil noticed it could have a lot more value to the economy by, instead of exporting cocoa, exporting the semi-processed cakes of cocoa. So there's a stage, adding a stage to the process and adding more value to the exporting country. So breaking down in stages like that is not just for the high-tech sectors, but it's a valuable thing to look at across the board.
Yeah, that's kind of like Nitya's comment too about the commodities. Is like you have, let's do lithium. Let's say I'm some poor African country with lithium, but next thing you know, Tesla shows up because they can make batteries out of it. You know, and so you go from the commodity into something like, I know you zoom that out, but I mean, that's something also to kind of think about.
Right. So sorry. Yeah. So can you repeat your question again? Sorry, I didn't. Sorry, I missed this. Some point.
I'll yell louder so it goes through the office. We'll talk about it. It was just about how, no, Paul, and this is about how you have something that looks really simple, but you can convert it into something that's really complex. And then it kind of fits in with Georgia. Your endowment allows you to do, I'm kind of thinking your endowment allows you to do that. Like it's like the Brazil example. I have tons of cocoa, but then I can convert it into a little bit more complex product by adding through the processing. And then I'm like doing lithium into battery. Nitya's doing copper into, I don't know what you do with copper. Like,
well, I think that's out of like a sample. Yeah, hopefully like focusing only on manufacturing sectors are gonna partly address that concern that maybe countries differ in endowment of the commodities. Yeah, but I agree it's not perfect. Yeah.
But I'll sort of jump in here. Maybe that's important, right? Because a lot of these less developed countries have a lot of commodities or have a lot of commodity or agriculture, and you want to kind of think about those things as well. For me, the thing I'm kind of struggling with is, the economy is not efficient, and you're seeing these like dynamic losses. And I know you sort of feel like you know where they come from, but it'd be nice to sort of just take the global planners problem with whatever technology you identified, and then show us like what happens. Are there long run dynamic gains, or is there something like in some models? What ends up happening is like when you change trade barriers, people like change kind of they're not willing to make the investments that yield like kind of long run growth, and so it's actually efficient to kind of have maybe a smaller economy in the future, but you have bigger gains along the transition. So if you did the planners problem, I think it would help me to kind of understand, what's kind of going on here.
Right. Yeah. Right. So we haven't done that, but that's a great suggestion. Maybe we should think about that. But in the simulation, it's true that in a simulation that like although countries have dynamic losses, most countries, like all countries, actually have a positive total gain. So it's not like a trade is hurting, like trade is hurting like each country. So if economy is efficient, no country can lose from trade. What do we find in simulations that although some countries have dynamic losses, static gains are larger than dynamic losses. So in total, all countries are gaining. But I guess, I
guess that speaks to like, when we did most of the trade liberalizations, we should have, if we think about globally, if most of the trade liberalizations were around these the GATT rounds, those should be periods of like really big growth, right? And like the first GATT round was kind of ended in 72, the first real one, the Kennedy round. We don't think the 70s were a particularly good period for growth. So I think trying to line up the model with like actual evidence on growth would be useful. Because as you said, like if all the losses are kind of backloaded, maybe this is another story for why we have like trade fatigue now, because really all the benefits were to like previous generations. So.
Right. Yeah. Right. I see. Yeah. Yeah. I think we should think about like planners problem and then how this inefficiency is magnified through trade. Yeah. Definitely something worth thinking about. Yeah. Right.